That's true. Give them many stars.
I know.
Well, oh my God.
Yes, coffee. That's sugar, protein. I should. Oh, good. Because I'm on the down slope towards the other.
Hi, everyone. Thank you for making it to the final and, of course, another very exciting session of the conference. So the way this will go is a little bit different. The person who has been delegated as your fearless leader will come in the front, and they will give us a summary of what was discussed. And then there will be like 1 minute for question or whatever emotions you have about what was discussed. Or hot takes. I like that. Yes, thank you, Rachel. All right. So topic number 1. Roman's core community surveys are going to be defined by a community process. How do we as a community want to be able to engage with this process? And what do we want to come out of this process?
Okay, hi everyone, I'm Jasleen. So I've been delegated to read out a lot of bullet points on this. So the first point we had, which the group thought was the most important thing about this, was that the process should be inclusive on multiple axes and have stakeholders from all career stages, including early career scientists. Rubin, for example, has excellent community engagement, which reflects their commitment to solicit feedback, accept and discuss criticism, implement changes, and give credit, a thorough follow-up process. There was also another point that there has been no response to early definition white papers, and it's been a year, and they would like more information on this process, have a more timely process, have stricter deadlines, and then a planned forum, also an iteration forum, so a planning forum and then an iteration forum. And that these dates and events should be available on a community forum that is searchable. Also, an ability to make an account for users to submit their ideas and feedback on that, and have a branching and expanding community that can gain the skills to do this kind of problem solving on the fly, and also do all of this planning in advance because compressed timeline. Also, there should be a clear outline of what is up for change, not in terms of hardware, but survey design. So, for example, the supernova survey cares about depth, but studies of galaxies or environments of galaxies may, however, require depth, but would then prefer to look at a patch of sky where there are galaxy clusters. And for example, the use of the PRISM in various surveys is important because the PRISM might be better for deep spectroscopy than GRISM might be. PRISMs could also be particularly useful for star formation histories or individual galaxies. Roman observing strategies already have multiple position angle observations planned, but it's important to understand how those positions can be optimized for multiple goals. And then, oh God, there's so many points. But basically, proposal nominations are competitive and not everyone may have the tools and resources to participate. So it's important to ensure that the playing field is level there. What else? Oh, there was a really important point here, so I'm going to skip to that one because it seems quite long. We want an explicit connection for the time allocation committees to gain information from the project infrastructure teams. And we want this regarding their expertise, such as core science figures of merit and merit effects. And also, it just seems like people want better communication between the scientists and the science centers. So that's it.
Any additional thoughts on that topic? Questions? Okay. That was perfect. Thank you. Okay, so moving on to topic number 2. What are your plans for dealing with the torrent of data?
All right. Good afternoon. My name is John Wu. I was voluntold to present here. So, all right. I don't know which way to face, but anyway. Right. We covered a couple of different topics. I guess on the emotional front, we were all very scared. There was a lot of fear and trembling about what will happen when the big torrent of data comes. I mean, to some extent, and we heard this in some of the talks, we know that a lot of our current methods in terms of analyzing, cataloging data, even, running through our pipelines, they're going to need to be accelerated with next generation techniques. And so machine learning is probably going to play a role, even if we haven't decided how those algorithms will do that. So we do think that that's going to help. We spent some time discussing the advantages and disadvantages of using commercial cloud platforms. And of course, that is a part of the plan. In addition, we think that having an accessible science platform is going to be a paradigm shift, but it is also important to this idea of connecting the compute and users to the data rather than bringing the data to the users, just something that doesn't scale as well. And so we recognize that, in all this, there's going to need to be a lot of communications with the community. There's going to need to, we need to have goodwill, from the project down through the science centers to the, all the researchers, and especially, I would say reaching out to a next generation of researchers for whom this style of processing will become the norm, or this style of research will become the norm with survey data. We just want to make sure that, we're able to provide what is needed for the science community. And then, some of the other suggestions, I may have missed some here, but one of the suggestions that was posited just now was to, have simulated data for early data previews. In addition to, familiarizing users with the tools and the cloud paradigm, as well as using the science platform, which should go live hopefully in a year or something, or not go live, but be ready. Having early access preview is useful for debugging. It's useful for building goodwill with the community, and it also just gives people a chance to, be familiar with how the data will flow and how the calibration pipelines and things will work. So these kinds of things will at least help ease the transition. I mean, there's still going to be a big jump up as we go from, the current paradigm to what Roman will bring down. But I think that, with these kinds of steps, we can start to address some of the challenges. So that's all I got. I don't know if anyone else has more. Nope. All right. Thanks.
Questions for group 2? Thoughts online or? Yes.
So you mentioned that there's advantages and disadvantages of storage on the cloud, and I wonder if it's anything more complicated than, it's just going to cost money to do it on the cloud. I was wondering how in-depth your discussion on what kind of the plus and minuses you guys discussed.
Yeah, thanks. Yeah, it's a complex topic, right? So from a costing perspective, it's unclear if it's a advantage or a disadvantage, right? Because if you were to maintain a server rack, and have things like redundancy control for that, go through maintenance and upgrades, and as you expand and if the mission goes beyond the prime 5-year mission, then you got to like build another costing exercise in there. A lot of commercial cloud platforms, like for that, there's not much you have to do. You just say, okay, I'll just double my allocation, and it's done. It also handles things like failover and having redundancy, all those kinds of stuff. It's actually generally more. There's much more uptime on commercial cloud platforms than there are on say an institutionalized server or something like that. So that's good, but it is bad from the sense of like we're basically handing some Silicon Valley company or whatever, some company and saying like, okay, like I hope you don't really increase your prices, or you don't do something like out of our control, and that's daunting. So that's just one of many potential disadvantages. Another one would be that people have to get used to the fact that it's living in some other place on the internet, but I'm not sure that really matters so much.
Hey John, I had a question. For cloud processing, are there wall times and restrictions, and would people have to be competing for processing resources?
In principle, yes. In practice right now, it looks like the way, so there'll be a platform, and the way the resources will be allocated there almost sort of limit you, like you don't have that many, you can't instantly scale up in a way that would cost NASA billions of dollars or whatever. So we may not have to really monitor CPU that much. We have not yet figured out but we have to, how to make sort of batch processing available from the platform. And clearly people are going to need to do batch processing, but we don't know how to do that and cost it and manage those costs yet.
Yeah, I'm just wondering, what if somebody tried to do some really deep, extensive, heavy processing on the whole high latitude survey?
Yeah, exactly.
And it takes 6 months, and
right. So
it's never going to stop.
Right. They won't have the resources to do it on the platform, so they can't run up the bill, but people will need to do it, so we got to figure it out, but we don't quite know how. I mean, it's possible to do it on Amazon. It's really just a question of how do you get the money transferred appropriately.
It sounds like the Roman data volume is a complicated and complex topic.
I mean, is it a possibility that somebody could pay themselves and use the same infrastructure, but pay separately, like
yes,
use all the data?
That's possible now. Yeah.
So thank you. Please continue this very good discussion on Slack. We will combine the notes with what you had there before, with what other online comments are, and we will make them available for everyone. But moving on to topic 3, which my computer just froze. But the idea is, how do we as a community are going to propose for general astrophysics programs such that they are not simply responding focused questions, but are increasing the overall legacy of Roman data? Yes.
Thank you. Hi, everyone. I'm Matt Hosick. I'm the speaker for this group, and group members out there, feel free to speak up if I forget something. But yeah, so we had a couple points that we settled on. The main one, really, which kind of sounds straightforward, but if we want these programs to be really focused on survey science, we have to make sure that the call for proposal that the TAC puts out emphasizes this, right? It should be clear that the TAC is going to favor proposals that have large collaborations across multiple disciplines, multiple science cases, programs that will produce science-ready data products that can be shared with the community. There was also a thought that it would be very valuable to use these general astrophysics surveys to leverage pre-existing multi-wavelength data sets, right? There are parts of the sky that we've observed in many different wavelengths. Well, how can Roman add to our knowledge of these really well-characterized fields? What can they add? there was also a consensus that it would be a good idea to think about ERS-style programs for Roman. Maybe take the first year of GA surveys and say, look, let's focus on proposals that's really going to test out the capabilities of Roman to demonstrate to the community what's the depth, what's the resolution, how does it compare to Hubble, how does it compare to JWST. And also an emphasis on that ERS program to produce software that is open and shared with the community to reduce the data or process the data, or things that can be run up on the cloud up in the Space Telescope to work with the data. And it was also important to fund those efforts because that's a lot of groundwork, and that groundwork requires funding. And I would say our group actually came up with some questions for the community, so interested in folks' thoughts. One thing we thought about was that it would also be valuable to think about archival proposals with Roman. We weren't sure how much this has been thought about. I don't know if anyone can think of that, but we thought this would be valuable to emphasize the survey aspect of the telescope. And sure, archival proposals might be part of the 25% for GA, but it's going to take a slice of the funding pie, right? So how does that match in? I think that was, and we should also not forget the overhead that's going to take in order to reprocess. So if you want to take data, sure, it's going to be processed with the regular pipelines, but if you have a science case that's going to need reprocessing, that's going to come with a cost. And so that's something we should keep in mind, and allow for people to propose to say, look, we're going to do this science. We're also going to need to reprocess the data for whatever cases. And I think that pretty much covers the main things our group talked about.
So I wonder if I might offer a sort of a comment on what I think you were saying about, are we thinking about the utility of the archival aspect of proposing? Now, the paradigm that we're trying to sort of infiltrate into people's subconscious here is that people will write proposals to do something with Roman data. And sometimes you might need Roman to go and point and take some data, and sometimes you might just be using the archive, and sometimes it's a blend of those things. But that from the user experience side, it shouldn't really matter which of those cases you're in. You're writing a proposal based on your science, and whether it involves the telescope pointing shouldn't be relevant. So every proposal needs to make an argument in that case, whether it's archival or new observations, because they're all the same thing. And I think, is that something that people are thinking about? Is that the way you're thinking about it? Or were you thinking about it like, this is Hubble, I'm going to apply for time, I'm going to get time, I'm going to get data? Because that's not the way I've been thinking about it.
Yeah, no, I think our group said the archival proposal aspect is going to be really important with everything. So, but yeah, how does the funding pie work, right? How does funding get distributed with everything? I mean, that's a whole nother technical issue, but that's something that's going to be thought about because this is going to need funding to do.
So
very cool. Awesome.
Just a sort of a quick reaction to that, having served on TACs, where in some sense you are doing that. Even in the HST TAC, they're in the same panels and they're talking about them. At some level, it's a little weird because the resource that you're allocating in the case of something that doesn't have observations is just money, basically. And the resource when you have observations is telescope time. And I'm not sure the most efficient way to have those discussions is to have them in the same discussion. I mean, obviously you have to balance the money somehow eventually. Telescope time doesn't have to be balanced against archival proposals. So I'm not sold that that's the right approach, personally.
Thank you. That was very informative, and it clearly elicited a lot of additional discussion. So topic number 4 is, what are the most exciting prospects for Roman for exoplanets? Roman study of exoplanets.
Okay. So as around 50% of the group who was talking about exoplanets with Roman, some of the ideas that we came up for that we thought were the most exciting prospects were, first from the microlensing survey, we're actually going to be
able to detect solar system-like systems. So not only, Earth analogs, but also Jupiter analogs. And because we'll have sensitivity between like 1 and 10 AU from the host star, where we really haven't had a lot of sensitivity from previous surveys, we can actually look at things like, the occurrence of Jupiter's relative to things like the ice line or ice lines in protoplanetary disks. So we can say, does the occurrence of Jupiter's peak at around 1 AU, as a lot of these RV surveys have predicted, or do they look more like our solar system? We have, large planets that are closer to 3 or 5 AU. And, which sort of scenario is more common? Do we see a lot of evidence for things like grand tack in other exoplanetary systems? Also, we can finally try and establish the occurrence rates of free-floating planets, which we basically don't know at all at this point. And then we can say, does that actually change in different galactic environments in different areas of the galaxy? Also, we're going to have demographics of more giant planets than ever before. And so we can start to look at how does planet occurrence change as a function of where you are in the galaxy. How do things look in the bulge relative to the Kepler field? We can also look at other fields, such as different directions in the galactic disk, or the thin versus the thick disk occurrence rates. We can look at different clusters that have different ages, different metallicities. We can even look at clusters that potentially have extragalactic origins and see how that affects the occurrence rate of exoplanets. And yeah, we can, in general, the sort of galactic habitable zone, that's something that Roman is going to be able to probe and get different occurrence rates for better than any other mission. So, got to look for exoplanets all over the galaxy with Roman. We can also detect, systems with disks. So we can think about looking at, again, young systems, obscured systems, and we can even think about relations to, looking at, other galaxies and trying to say, okay, we see a really dusty galaxy. Does that mean that there's potentially a planet there? We still have to flesh that out a little bit more, though, I think. Also, in terms of follow-up, JWST imaging of the bulge fields, for example, will give population level statistics of host stars, so we can give sort of statistical properties of the planet hosts in the bulge. But if we want to get, follow-up of individual exoplanet hosts in the bulge, we really need access to ground-based facilities, and we need, some of the largest telescopes with really high throughput so that we can actually follow up these individual systems. So the current sort of, 10-meter facilities right now can just barely detect, hot Jupiters in the galactic bulge. And so we need to think about the balance between, throughput and RV resolution when we're trying to prioritize what sort of ground-based missions could do the best sort of follow-up of these exoplanet systems found by Roman. Also, we just need more. We're going to get more M-dwarf systems. Those will generally be the easiest to follow up because those stars are fainter, and so they'll generally be closer to us, within sort of 5 kiloparsecs. And so they're more likely to have small planets that we can detect as well. And so maybe we can do a lot more follow-up of the sort of M-dwarf systems that are found by Roman. And actually, we're finding that there are a lot more giant planets around M-dwarfs than we might have originally expected, a couple of years ago. And so there might be some M-dwarf systems where atmospheres can be well characterized by James Webb that Roman finds, especially if they're in different areas of the galaxy. That could be really interesting for sort of comparative exoplanet demographics. And also, brown dwarfs will be discovered in huge numbers by Roman. So, that'll give us new information about the IMF, the initial mass function of the sort of lowest mass objects in our galaxy, as well as giving us information about their atmospheres and the chemistry of those objects. And so then we can start to ask questions like, okay, how does the brown dwarf occurrence rate relate to like the free-floating planet occurrence rate? Is there a continuation of the IMF at these lowest rates, or do we see, an excess of planets or things, or brown dwarfs even, that have been ejected from other sort of binary systems or planetary systems? And then finally, we talked a little bit about the coronagraph mission. Right now, there are only 180 days that have been allocated to the coronagraph survey. And so if we find interesting things, are there good ways that we could extend that survey and try and detect more good imaging targets with Roman? That's about it.
Any additions to that? Comments? Questions? All right, thank you very much. Moving a little bit farther to the Milky Way and nearby galaxies, what are the most exciting prospects for those studies of those, the study of those?
Okay, so we were a pretty small group, but I think we covered pretty decent ground here. So we tried to focus, I think, a lot on the core community surveys and what type of exciting science that we're going to be able to do with that in sort of the local group and near field. And then we focused on a few other things that were maybe geo program related. So for the Galactic Bulge time domain survey, I think we were particularly excited about the ability to do kind of astroseismology on stars in the galactic center, to allow us to calculate or measure ages and proper motions of giant stars, many giant stars in the galactic center. Also very excited about we're going to detect a lot of variable stars in the galactic center as well, of all types. And I think one of the things we were thinking about was trying to make sure that the cadence of observations covered the full sampling of the periods of different variable stars to make sure that you're able to detect the full range of these things. In the future, I think maybe a geo-related thing would be to try to do this this would be a big program, but to try to do this for maybe the halo and the dwarfs of the Milky Way, and also maybe expand this to Andromeda as well. Then for the high latitude wide area survey, and I guess I'm going to combine this with the time domain survey as well, but a question we had was kind of what we could do with slitless spectroscopy. We weren't super sure what kind of things we could do with that, but we thought about maybe getting being able to get rough metallicities, maybe for through something like the calcium triplet and major features like that, and temperatures of stars. So a thought that we had was perhaps you could combine the variable star measurements, things like R Lyrae's, the period luminosity metallicity relation, with the slitless spectroscopy and TRGB distances as well for some of these outer Milky Way local group dwarfs to get more accurate distances. Something that I talked about this yesterday that we think it would be very exciting is if the high latitude wide area survey were to cover maybe one or two nearby Milky Way-like group environments, things out at several megaparsecs, or something like Sculptor Group, which would cover Centaurus A, NGC 253, or the M81 group. Those are at opposite ends of the galactic in galactic latitude. But either of those would be really great because both Centaurus A and M81 have many bright dwarf galaxies that we know about now. We haven't heard a lot about what Roman is going to do for detecting faint dwarf galaxies yet at this conference, but I imagine that both for Cen A or for M81, we would detect dozens of ultra-faint dwarf galaxies. This is something that has never been done, right? We heard maybe a couple of ultra-faint dwarfs that have been detected in the field, very spurious things, or perhaps one in a cluster environment as well. But populations of these things that we would be able to detect just in this, already planned survey if we were to cover, one of these things. And so that, that brought up the point that, since we're deciding still where to point for this high latitude, wide area survey, that, it'd be great to really think about, science areas where the placement of it really matters, right? Especially for these nearby groups. There are only a few of them. And so, deciding where to point so that it could include one of them would be really interesting. Yeah, I think that's about it. I think that's all we covered. Do you guys have anything else? Cool.
Questions, comments for this group?
Thanks. Yeah, these are actually these are super exciting to me too. One thing that I'm also really interested in addition to what you just said, is the prospect of looking for stellar streams and looking at the impact of halos of, where you have like dwarf galaxy satellites, and we might even be able to constrain really the faintest and trying to find dark halos that may be perturbing the stellar halos. Yeah, these are dark matter, halos without dwarf galaxies in them. So I think there's a lot of interesting stuff there too. Another consideration I guess is worth mentioning is that, like, depending on what distance scales you're talking about, like how far away these nearby galaxies you want to look at their satellite systems. Like at about 50 or so megaparsecs away, if you're okay with the unresolved stellar populations, you'll be able to like hit the entire virial radius in just 2 pointings. And so you could also imagine getting like several hundred, Milky Way analogs very, very quickly with some sort of geo program. So,
yeah, those are really great points. So for the streams, I think, something like Sene would be really exciting. I mean, I know Sarah Pearson has already done some really cool work on, running some of these stream detection algorithms that folks have been running for Gaia, for the Milky Way, and running them on the, specifically, I think she ran it for Sene for the MegaCam program that Daniel Kornejevic did for that galaxy some years ago. And you can do really well, and I think that would be, something for, would be really cool for detecting these dark halos, for example. And for other, more distant Milky Way-like groups, I think you could do a lot with these, streams and dwarf galaxy populations. The ultra faints are going to be beyond our reach because there's going to be no diffuse brightness. But yeah, both also good points. Yeah.
Wonderful. So moving to topic number 6, what are the most exciting prospects for Roman studies of galaxy formation? Yes.
All right. I'm Ali Kostovan from Rochester Institute of Technology, and in the group I was the one with the laptop, so I guess that put me up front. And we had a lot of ideas. We were a big group, and there's a lot of discussion, and I'm going to try to limit this to the 2 to 3 minutes. So starting from where? Because it's just a mix of all of these wonderful ideas. One in particular was that we talked about environmental studies. So Roman, one of the biggest advantages is that wide area. And that would really enable us to not only go after, just field galaxies, but also even, sorry if I said something, but also even protocluster-like environments, rich cluster environments, also even potentially voids as well. There was discussion of how these protoclusters in the high redshift scheme could be, used to identify places where there are ionized bubbles. So in order for us to study reionization, how that occurred. And there's also a synergy that is potentially available between Roman and JWST. So for example, if we find protoclusters in Roman, we can, we trace them, for example, via their Lyman alpha emission. We can follow them up with JWST to go after rest frame optical emission lines, H beta, maybe H alpha, and so forth. Let's see, what else was there? There was discussion regarding weak lensing, how we can use that to measure dark matter halo properties, the stellar mass halo mass relation. And we didn't talk about this, but I thought about it after reading this over again. I mean, with the amount of sources that we'll also potentially get with Roman, we could even do clustering analyses as well. So galaxy-galaxy correlation function studies, that would give us some valuable information regarding dark matter halo properties and also enable us to investigate how host dark matter halos can actually influence the evolution of their residing galaxies or and so forth. And let's see, what else did we have here? There was also emphasis on having, even though it's not planned, but a little push to have K-band data also somehow come in. There was some discussion about that. That would be quite helpful on multiple fronts. One is for really high redshift dropout galaxy selection. Another side was also to separate the low-Z galaxies from star-like sources in color space, which will allow us to also find some low-Z galaxy interlopers in searching for quasars, some really high redshift quasars. And there was discussion also for a ultra deep Grism spectroscopy as well, where we would be able to go after some really high equivalent width emission line galaxies. So some very like low mass, very bursty type galaxies. But it would also be quite beneficial in order to make like statistical property measurement, like for example, luminosity functions. So we even saw in like Isaac's talk today how he used the logger survey to really try to differentiate which evolutionary path it is for reionization. Is it a rapid? Is it a gradual reionization path? With an ultra-deep Grism spectroscopy, we could potentially even do that by having really robustly constrained like luminosity functions to use Lyman alpha luminosity functions. The last few things, morphology, understanding the origin evolution of the Hubble sequence, also specifically like star-forming clumps, having spatially resolved SCD fitting as well, having dust maps, star formation maps of galaxies, identifying regions where star formation activity is quite active inside galaxies, also galaxy mergers, how merger-driven star formation activity occurs. And the last point was also potentially looking for strong lensing systems, where one mentioned that Roman would be able to find 400 cluster scale lenses, and 1,000 galaxy scale lenses, and I guess a single pointing, if I understood that correctly. Oh, sorry, you go ahead. Sorry. Thanks. So not in every single pointing. Sorry.
Your question, your wish is answered. Roman does go to 2.3 microns, at least in imaging.
Mm-hmm.
So or you were thinking more spectroscopy when you said the K band.
For imaging, yes.
Yeah, 2.3. So.
Okay, I thought there was something said that it was for like the time domain only, or I vaguely remember something.
Oh, I see what you're saying. Okay. The filter is available. Okay, got you. So there's a comment there. Oh, okay.
Okay. Just to continue the comment on the K-short. It's not currently in any of the design reference missions because those were made before that filter was put in, before it was on the mission. So none of the core sciences have really thought about how to use it. So bring it up, great. I support that. Another thing to remember about it is it's about 1 magnitude shallower for the same exposure time as the F184. So as we think about what science we want to do with that new filter, it does give us, as you pointed out, a ton of science capabilities. But we've been thinking a lot about how to use the other filters, and this one's newer, so we need to think about how to use this one.
A 5 sigma AB magnitude for the 1.95 to 2.3 filter is 26.2 magnitude. I don't know if that helps you right now, but.
Well, still, I mean, I would say that even if it's shallower, I mean, think of it this way. Before JWST, going down to like 26, 27 magnitudes in K-band, wow. With JWST now, it's happening, it's great, but it's a small field of view. Now imagine like you can do it in such a wide field of view. I think that's the biggest benefit to it.
I'd say another nice thing about K-band is your interstellar extinction impacts you less. So you may actually be able, for high extinction regions, you won't be able to go to as deep magnitude, but you may see sources that at shorter wavelengths you're not sensitive to. I don't know how the calculations work out, but you do get that boost.
Thank you. Any other thoughts, comments? Has your group considered the inclusion of multi-wavelength fields, meaning like pointing to regions where you have an abundance of ancillary data to support a wide range of galaxy evolution questions?
Yeah, I think we didn't actually but you did? Okay.
Yeah, I think our group has mentioned about that. It's like if we have ancillary products from like others, like fields, probably HHSC, SSP, that would be perfect because that will allow us to do more science related to other wavelengths too. Yeah.
So I should also mention, I mean, there was a lot of discussion also regarding like follow up with, with JWST, with there was something I think written even there regarding ALMA, but yeah, I mean, if it's pointed towards rich fields like Cosmos, for example, then we get a lot of return for that.
Group. So thank you again. Were there any takers for the Choose Your Own Adventure group? Ben, Rose.
So my choose your own venture was I was wandering around between tables, which means everything that I did has already been said. So I don't know why the mic got passed.
Okay, well, this ends our conference. So thank you very much to all for coming. It was a pleasure to hear your research and insights and question and advice for the SOC and the SSC and the PITS, maybe. So thank you again and have a good flight home. If you're done here.
We're supposed to remind everyone that this is a series of conferences, and the next one will be hosted by IPAC. So just, if you're interested in continuing to have this conversation about Roman, try to get on their mailing list on their website, and they will send out information when they start planning. Right, Skylar? He may be gone. Yes, he is gone. But, yeah.